radio. Voices crackle through static glow. Morse code tapping in the night. Underneath the stars so bright. Connecting folks from far and wide. Waves in the air they provide. Call signs echo through the ether. Let's get closer, let's go deeper. Amateur radio roundtable so fine. Join the chat and realign. From HF to VHF, we're all here. Let's make the distance disappear. Twist the knob, find a friend. Airwaves never seem to end. CQ calling loud and clear. Sharing stories ear to ear. Antennas point to the sky. Signals rise and amplify. Tuning into hearts worldwide.
All right, now Mark P, that is version 7. That's version 7 you sent me, so I don't know. Maybe I don't have the latest there, but well, we will look for
Yeah, he
it.
says it's the wrong video.
Well, version 7. All right, Mark P, am I supposed to be using version 7, or did you send me another one I haven't seen yet? Anyway, okay. Hey guys, welcome to Amateur Radio Roundtable. It's a show about ham radio, shortwave, electronics, and all those kind of things. And we're glad you're with us tonight. If you're out there listening on international shortwave on WBCQ on 7490, we would love to hear from you. Please send us an email to tom@w5kub.com, tom@w5kub.com. Let us know where in the world you are and how you're hearing the station. We'd love to get emails from you. I heard somebody say something.
There was echo from somewhere.
It may be on my end. Okay. And if you will, click that subscribe button down there on YouTube. We're on YouTube tonight. We're on x.com, and we're also on our Facebook group. Our Facebook group is called W5KUB, and we've got about 14,000 members in that group. So please join in that group. Just do a search. The actual group has another name. The group is Amateur Radio Roundtable, but that is so long to key in, you'd go to sleep before you finish that. So if you just key in W5KUB, it'll take you to the same Facebook group here. So, hey, we're glad to have everybody on here tonight. And I think we've got a good show lined up tonight. We got some shack pictures of Novice stations. I wanted us to look at some Novice stations tonight. And let's see. Hey, Hambot is here tonight. Hambot's going to give away a ARRL $25 certificate. Now, I had a discussion with Hambot, and I talked to Hambot, and look, Hambot picking a random person is not going to get this to someone that can use it. So what we're going to do is, a little later, when I ask you to, if you want the gift certificate, you have to say in the chat room you want it, and we'll take probably the first person that in the chat room that says, I want that gift certificate. So don't do it now. Don't do it now. Wait for the cue to say you want it. And that way we can be assured that somebody can get it and use it. Yes, there is an expiration date on it. It's August, the end of August this year. So you got plenty of time to use it. And, ARL's got a lot of books and different things. And, hey, you might can use this. All right.
I was going to say, you've got plenty of time to use it and buy my book.
Hey, you can buy Glenn's book right there. $25
There you go.
off. Glenn, what's your book selling for?
I think it's $34.95.
Look at there, $34.95. You can get this thing. You can get his book for about $9, man. That's all it's going to cost you.
Yeah. Just don't
Okay.
drink Starbucks in the morning. Use the certificate, and you're good.
That's right. Okay, so let's do this too. Just a couple of things coming up. We got shack pictures coming up. I put together a video. You know, we've launched a balloon for the Arkansas River Valley Amateur Radio Club. It's flying right now. Its call letters are W5 KUB-118, and it just made it across England. It's crossing the water, and right now, I think right now it's in the Netherlands. So when it wakes up in the morning, it's going to be in Germany, and from Germany we're going to go across Poland, and then we're going to hit Ukraine. We're going to go across Ukraine, and then Russia, and then on to China. Now, we're putting contingency plans together for when we go across Ukraine. We think we may be flying with a lot of drones and a lot of Patriots. So we're going to have to. We're going to try to figure out what we're going to do there. But it's flying very well. It's flying at about 43,000 feet, and it's been up to 145 miles per hour in the jet stream at times. So I put together a little video. A lot of people are asking, well, how do you gas the balloon and whatever? So I put together a little video that talks about the balloon, how we stretch it, how we take the air out, how we measure the hydrogen and put it back in the balloon. And then we got just a short couple minutes of that. It's going to be the actual launch of the balloon. It was a perfect launch. We're going to see that in a little while. You know, last week we talked about Ethernet and splicing the Ethernet cables together, and Brett says, hey, you're going to have an impedance mismatch and all that, and Brett's right. But guess what we're going to do tonight? I got a video here in our $1 million lab here. We took an Ethernet cable and cut it in half, and we spliced in 30-year-old lamp cord and some new lamp cord, some doorbell cord. We spliced it all in there, and we ran the speed test. You're going to be amazed. You may not be amazed, but we're going to let you guess what kind of speeds we might get. So we got that coming up there, and of course Hambot's got this prize he's going to give out here. Okay, well, let's go around the room here and just see what's going on here. Well, let's go with Brett first. And Brett, how you doing here, man? Did you have a council meeting tonight, or is it every Tuesday?
The city council is meeting. I'm not there. I put my comments in early to the council. They are giving out money to nonprofits, and so the nonprofits are doing dog and pony shows for all of them. It's going to be a long evening. I'm glad I'm here. It's more interesting, I think. But what I've been up to in general, I've been working on recapping a transceiver, and it's a lot of unsoldering and resoldering and being really, really careful not to lift the traces off the board, and I desolder. And I'm using, depending on where the thing is, I'm using wicks and solder suckers and just trying to do a good job and not mess up the circuit. We'll see how I do. When I get it all back together, if something doesn't work, I'll have to figure out which cap it is that I didn't do right. So I'm hoping for the best. I'm hoping I don't make any mistakes.
Well, I'm sure you'll do good there. I like to just take old boards and pull off components, and that's how I get a lot of my components. You mentioned a solder sucker. I got the manual solder suckers. You press a little spring down and pop it. Sometimes it works, sometimes it doesn't. At Russellville Hamfest last year, I bought a vacuum soldering. Well, it's not a soldering station. It's a vacuum desoldering station. It's got the vacuum hose on it and everything, and I haven't really tried it yet, but I think it'll work well. And I tell you, one thing that works just really well, like you mentioned, is the solder wick, the braided stuff. That really cleans a connection up really good there. And, you know,
So
hey,
what kind of radio are you doing there, Brett?
An old Kenwood, and it's got a lot of it's almost all analog except for the display, and it's got a lot of got a lot of electrolytic capacitors buried in there. It's hard to even find them all sometimes, but
Wow.
yeah, if you take the boards out and you're patient, you can do it.
all right, well, you know, clean it up, make it look brand new. You know, I mentioned on the show before, uh, back when I started on 2 meters back in the 70s, my first rig was one of those taxi cab tube radios, about this big, 30 pounds. It was actually washed in a dishwasher. People were actually, that's a known way of cleaning those radios. You put the radio in a dishwasher and it actually cleans it. Now, of course, you got to let it dry out really good, but the thing looks spotless, you know. I mean, it sounds bad. Glenn's shaking his head, but that's the truth. They were
Yeah.
washed. They were washed in a dishwasher.
Oh yeah, I use alcohol, so I have a better shot at getting it dry. But you can use water.
Yeah, yeah. All right. Well, all right. Well, you're gonna have to help us with our Ethernet segment tonight, man. You know, we're gonna.
Glad to do it.
Yeah, yeah. And look at there, Glenn is texting right now to somebody. I don't know, if his girlfriend or somebody on there, not paying attention to
Yeah.
the show. Glenn, what are you up to?
No, hey, I can do 3 and 4 things at once.
Yeah, yeah, yeah.
Well, I've been finally working around the house, getting stuff done, and I actually found my end fed the other day, and putting the shack together. I got the power strips mounted on the walls now, so the power's set up, and so we're slowly but surely getting the shack put back together, and getting ready to start building some stuff in there. So the good news is, you know, I'm not having to go to that cardiac stuff 3 days a week, and that's freeing up my time to get done, because whenever I go there, it's physical therapy, and it wears you out, but you're useless for the rest of the day. And that's done with. I get to see the cardiologist again in May, but I'm all good.
Yeah, okay, very good. Sounds positive here, man. I think you're on the right track there.
Oh yeah, I think it's going to be fine.
All right. Let's see. Anything else going on? You going to get that antenna up soon? You found it.
I found it. That's the big thing. I've got to do a window pass through for the coax. I've got like 7 runs of coax planned, so I got to get that set up and built. I can't use Martin's because it's just not right, but I had a friend cut me some metal, and so I'm getting ready to put that up. And once I get that, then yeah, I can hang the end fed into a tree and up it goes. And it's the 53-foot, I believe it's an Ultimax end fed.
53 foot though. That must not be a half wave. That must be a random. Is he got a 9-to-1 balun?
Yes.
Okay, it's a random link then. And
I don't think so.
Well, it is, because 40 meters would be 66 feet. For a half wave. It's not a half wave end fed. If you've got a 9-to-1, it's not a half wave. It's a half wave uses a 49-to-1.
All I know is I shouldn't need a tuner for 40 meters.
Yeah, a half wave would use a 49-to-1 and a random length, and there's several random lengths that work well. 53, I think, is one of them.
53 is one of them.
Yeah, it would be a 9-to-1.
Yeah, I'm pretty sure it's 9-to-1.
Glad you're getting that up there real soon, and I'm thinking about trying to build a little, maybe an end-fed half wave. Or maybe a random link with a little bitty toroid for the balloon launches. It's got to be really small though. But I'm thinking about I tried a half wave end-fed here last week, and I couldn't get a match on it at all.
Yeah.
But it may be because the wire is the size of the hair on your head. That may have something to do with it. I have no idea. Plus the proximity to the ground. I had it probably 10 feet off the ground here. All right. Anything else going on?
No, that's pretty much it. I've been working around the house and spending most of the time in the shack now, so we're getting there.
Well, all right. Well, good. Good. All right. So let's do this. Let's talk about. Let's just jump into our Ethernet over lamp cord. Ethernet? Oh, yeah, that'd be good. Ethernet over lamp cord.
There you go. Yeah.
Let's talk about that, guys. If you remember last week, we talked about how it's not a good idea just to twist it. Brett showed us how to do it correctly, but we wanted to try to do it incorrectly, and just to see what would happen. So I've got a little segment here, and we're going to look at it. After this, Hambot's going to be around, and I'll tell you when you can enter for the $25 gift certificate right here. And but don't enter yet. Okay, let's look at this and see what we think here. And we may stop the video and ask you what you think. Here we go. I'm going to put let's see. On the Hey guys, last week on the show we talked about Cat 5 and Brett showed us how to do a real good splice and just do it upright. And we were talking about how if you just twist the wires together, it makes the impedance wrong, and it can throw in all kinds of things, and I'm sure it does. But I thought, let's just do an experiment tonight, and I'm going to take a Cat 5 cable. We're going to run some speed tests. I'm going to take a Cat 5 cable. I'm going to cut it in half. And then look at this. I'm going to splice in 30-year-old lamp cord, new lamp cord, doorbell cable. I'm going to splice all that in between the two ends of this Cat 5. And then we're going to run another speed test. And I want you guys to tell me what you think it's going to do. Is it going to be half the speed? Is it going to be a fourth? Is it going to affect it at all? So we're going to find out. But first, let's do a couple speed checks and get a reference. So we're going to come over to here and we're going to do a speed check. Here we go. Let's see what we get. I'll record these. All right, not too bad. We're getting 938 down. And up is a little slow. I normally get about 62 up, but I don't know why. Maybe back here in the shack it's different. But anyway, okay, we got 51 up, and we got 938 down. Okay, I'm going to run it one more time just to see how much difference there is. Let's see if it comes out 938. Probably not. We might even pass it, actually. Nope. We got 933 down. And we're getting about, going to be close, a little bit more, I think, than we had first time. No, we're getting 51.3 down. I think that's the same as it was, up. That's the same as it was last time. Okay, so there you go. Here's our up and down. I've got them recorded right there. Okay, so what we're going to do is, I'm going to unplug the Ethernet from the computer and put it in series with this cable. But first let me show you something. I'm going to test this cable and make sure it's good. Now I have a commercial Cat 5, Cat 6 cable tester, but why use a commercial one when you can build your own? Guys, this is Tom's cable tester. I don't know if you can see that very well, but I've got two RJ45 jacks on top, And I've got lights for each side of the Ethernet cable and a switch here. Let's take a look and see how it does here. So I'm going to take this cable that we're going to test later and make sure there's no shorts or no opens in the cable. So I'm going to just plug it in my Tom's cable tester here, and we're going to see what it does here. Okay, here we go. Okay, there's no shorts between any of the cables. All of them have continuity through. That's all Tom's cable tester checks. And if you want to build one of these, they're pretty simple. If you can find the parts. I had parts in my junk box. Look there, I've got like a 12 position switch. Boy, it's got a lot of different wafers on there. I think I'm only using one. And then, of course, I just glued the LED lights in. I got a little 9-volt battery in here and a dropping resistor to drop the voltage. All right, but that's it. All right, so we know our cable's good. So I'm going to do this. I'm going to take the cable. This is a good Ethernet cable. Wow, real good one. But I'll sacrifice it for the show. I'll sacrifice it so. I've got hundreds of cables, and I can build my own. But this is a nice cable. I probably shouldn't cut it in half, but for the show, we'll do it. All right, so we're going to put it here, we're going to put it here, we're going to come down here, and we're going to find about a halfway point, and look at this, look at this. Oh boy. Uh-oh. No connectivity now. Okay. So what we're going to do, we're going to expose each of the 8 wires in here. Let's see if I can get this insulation off here real quick. And I'll show you what we're going to do. Maybe. Okay, that's a pretty good cable. All right, there's our 4 pair of 8. All right, so what we're going to do is we're just going to splice this junk wire in between these. So, hey, I've got this one stripped back. You can see it. They're stripped back. Let's just pick out a wire here. Let's go with the new. This is a lamp cord, regular lamp cord, and I have marked. I've gone ahead and marked so I can identify which one of these is which. So let's just put this on the orange. We're going to use this on the orange. So I'm going to put one on the orange white stripe. We're going to twist it, and then put the other one on orange. Now I'll do the same with the other end of the cable. Whatever I did with it. Here it is. I'll do the same. I'll strip it, and we're gonna splice it by twisting it into the other end of the Ethernet cable, and then we're gonna plug this in and do a speed check. All right, we'll be back in a minute. Okay, all right, we have spliced all 8 wires of the Cat 5 cable, as you can see here, into the various lamp cords, the old lamp cords, new lamp cords, and doorbell wiring. You can see it looks pretty messy. I'm not going to tape them up. We'll just try to separate them, make sure they're not shorted. Oh, that one's about shorted, so we're going to have to kind of, need to do that. Okay, so we're going to do a speed test now and see how this works. What do you think? And guys, you may have to do this sometime. Hey, I was in the military, and I was taught that if the enemy's attacking, you may have to do something like this. You may not be able to go out and get Cat 5 cable. The store may be closed. The enemy may have that store. You just don't know. So you may have to use barbed wire in these places I'm here. I'm just showing you what to do if the enemy attacks, okay? All right, so let me move it. I'm going to try to move it without it all coming apart here. All right. So we're going to move this, all these cables. What a mess, what a mess. Down here. Now see, okay, we're going to check the shorts before, we actually plug it in anything. All right, so let's see what we're going to do. We're going to unplug the Ethernet out of the computer. All right, here's the Ethernet cable out of the computer. I'm going to use one of Brett's connectors or splice. Okay, and then I'm going to plug in. I'm going to plug in one end of it. I think I'll plug this end in right here. All right, let's see. No shorts there. No shorts there. I think we're okay. So here we go. I'm going to plug this into my gig switch. I don't hear anything buzzing or smoke. We're going to plug this into our computer. Okay. We now have our network connection through all these cables. Let's see. What do you think it's going to do in a chat room? Tell me. What do you think? Half the speed? A fourth the speed? All right. This is the time for Glenn, everybody, chat room. What's our speed going to be? We had 960 down and we had about 50 something up. What is going to be our speed with this stuff spliced together here? I need your best guess right here. Mark P is saying 100 meg. Okay, anybody else have any,
Yeah, I'm going to say it's going to be full speed at that short length.
You think so? All right, Glenn says full speed.
Yeah.
Glenn says full speed. It looks like Chris there, AC5CM, thinks it ain't going to make much difference. Let's see. Yeah. Okay, so Chris and Glenn have it. It ain't going to make any difference. Brett, you got any thoughts? 960 down? What do you think?
I don't know. I think it's going to depend at that short length. I think it's going to depend on how well you twisted them and also the quality of the Ethernet ports on your devices.
Yeah, well, I've got gig ports. I don't know what the quality is, but we'll see. Okay, anybody else in the chat room? Right now, it's time to put your number in. Is it going to be 100 meg? Is it going to be 400 meg down? Is it going to be 600? Is it going to be 22.5? Will it be 22.5 down? And okay, I'm just asking. Okay.
Well, based on the age of the wire, it could be 300 baud.
Okay, yeah, some of it. Okay, so let's see what happens here. Here we go. Will it affect it at all? Will it even work at all? Let me know what you think. All right, Glenn, you and Brett, what do you think? All right, here we go. Let's do a speed check. I don't see anything smoking yet. Whoa, look at that. Look at that, look at that. We get 94 down. Okay, 94 down. And we've got about 50 up, it looks like. I said 48.5? 0.52. Okay. All right, guys, so here's what we got. Look at this comparison right here. With regular Ethernet cable, we got 930 something down with 51 up. With our emergency cable, when the enemy's attacking, we've got 94 down and 48 up. Now, one of the things about this, I can tell you right now, if you're doing surfing or email or whatever, watching videos, 94 is plenty. It'll work fine for you. You don't need a gig down. 100 megs is fine. So look, we could actually live with this right here if we had to. We could live with it, and we probably wouldn't even complain, you know.
It's faster
All right.
than what I got.
There's one more thing I want to do. One more thing I want to do here real quick. Let me take this out of the circuit before I short the wires together. Okay. Okay, so you guys have probably seen these. You've probably seen these. These are Ethernet over your house wiring or your power lines. I don't know if you've seen them or not, but what you do, you plug this in at your switch, you plug this in at your computer, and basically you don't use Cat5 cables between point A and point B. You're using the electrical wiring in the house. Now, I've got almost gig down, but look, these are rated at 500 megs, 500 megs. So we can't expect anything more than 500 megs. Your computer would plug in one end, and your switch or your router would plug in the other end here, and your home electrical wiring in the walls actually then becomes your connection between your computer. Let's run this. Hey, and to make it interesting, here's what I'm going to do. I'm going to plug one in here, and I'm going to plug the Ethernet from my switch into here. Okay. Oh, look, we got lights. Okay. Now, all right. So now we got Ethernet into. We've got data running into our home power. Let's do this. Let's throw a wrench in it. I'm going to run it through this. I'm going to run data through this 100-foot extension cord. So what I'm going to do is I'm going to plug this extension cord in the wall here. Uh-oh, something happened here. Oh, okay. Okay, I plugged the extension cord in the wall here. I'm going to plug this one in the extension cord. And then we're going to take a cable, and we're going to plug this into the computer. Well, it says we have a link. All right, I'm going to plug this into the computer. Let's see what's going to happen here. I've got so many wires back here, it's difficult to get back here. Okay, now my computer now is going through this adapter, which adapts your Ethernet connection through your power lines in your house. I'm going through a 100-foot extension cord. If the enemy's attacking, you don't have Cat5, use extension cord. All right. And then over here, we've got from our router, our switch, we're coming into the other adapter here, and we're plugged into the power. Okay, so we're going through a 100-foot extension cord. What do you think? What do you think? Are we going to get 93? Are we going to get 48? Are we going to get 900? Let's do a speed check and see what we get. All right, guys, here's your chance. What do you think it's going to be? You know, normally we've got about 933 down in the ham shack. We're going through 100 feet of extension cord. 100 feet of extension cord here. Now remember, I'll give you a little hint. Remember these little adapters said they were rated at 500 megabits. So they're 500 megabits, I guess, is their max. So that'll help you out a little bit. So what do you think the speed is going to be? Normally we get 933, but now we're going through a 100-foot extension cord. All right. What do you think, Glenn?
That's a tough one. I want to say 100, but it could go all the way up to 500.
What do you think? What do you think, Brett?
Well, it depends. Those things, if they negotiate at 100 megabits per second with your Ethernet ports, that's the absolute limit. and then it's just going to depend on how good the connection is to your house wiring. If they were on two outlets that were on different phases, you'd get very poor connectivity. But if they're on two outlets that are right next to one another, it ought to be the capacity of the chips. So I don't know.
That's
I'm
true.
I'm gonna guess you're gonna get around 100, but
Okay.
that
All right.
yeah, I could be wrong.
All right. Mark is saying 100 meg max. Anybody else in the chat room got any ideas of what we're going to get? Okay, here we go. Here we go. It's going to be slow, I can tell you. Oh, wow, look at that. About like my lamp cords. Just about like the lamp cords. So, oh man, almost identical. We got 93.6, 93.6, and we're getting, and we're going to get 46.9 down, 46.9. So here's the results. That's Ethernet. This is my lamp cords and doorbell cords. And this is the little adapters to use your home wiring. Again, both of these are giving me almost 100 megs down. So that's pretty good. All right. Hey, I just thought, let's do one more thing. Let's take all the wires out. And let's just do what we talked about last week with Brett about just twisting the wires together and splicing. Let's run one quick test about just splicing the wires by twisting them together. This is no lamp cord or anything in between. I'm just putting the Ethernet back together where I cut it. All right, almost got it here. Wow, don't want to get any shorts. Okay. All right. All right. So there we are. We're all back together. This is going to be difficult to keep your shorts. Okay. Let's see what I'm going to do. Put a little piece of tape around it. Okay, so Ethernet cord, again, I've just spliced, twisted the wires back together. No special adapter in between or anything. I know the impedance is probably affected. Let's plug it in and see what happens here. Let's see how it works. So we're going to have to use a little splicer here. One end goes in here. The other end of our cable goes in the computer. Make sure we're not, I think we look okay. I bet we get more than 100 or, I bet we get more than 90 megs down right. Okay guys, this is our last test here. Now we have just spliced the two pieces of Ethernet cable together just by twisting each same color together. This is what we talked about last week. You know, Brett talks about how this does make a impedance mismatch, but this is our test. We just spliced it together. Remember, the enemy is attacking. We don't have that little adapter, that splicing adapter that Brett's talking about there. So we had to splice it together. What do you think it's going to be? Glenn, what do you think it's going to be?
I think it's going to be back to full speed because you're not causing enough of an impedance bump or anything with that twisting of the wires.
Are you sure about that? Or is
Yep.
that just your thoughts?
That's my thoughts.
I see you're on a scientific calculator there. You're cheating, aren't you?
Yep, I'm cheating. Now, here's the deal, though.
Yeah.
I'm still concerned with the AC power thing because you're talking about being in a battlefield. Where are you going to have an AC outlet that you can plug into in the battlefield.
Well, we have generators out there running all the time.
Yeah, but you're not going to run that stuff through the generator now.
No, we've made that a procedure. Any battle we're in, we're going to have a generator running.
Okay.
All right. Now, Brett, what do you think the speed's going to be? We got an Ethernet cable. All 8 are spliced together and twisted.
I don't know if that's good enough for your ports to negotiate at a gig, so I'm going to stay. So you're still going to get in the neighborhood of 100, most likely. If you're really, really lucky, they'll negotiate at a gig, but they might drop packets and slow your test.
Oh, wow. Okay, chat room, what do you think, guys? This is like a 10-foot or 12-foot cable, cut in half, twisted, spliced together back in the center, no extensions. Chat room, what do you think? What's it going to be? Normal is 933 down. Will it be half that? 450? Will it be 100? What will it be? Mark P says a gig, not long enough. What? Oh, see, he thinks it'll be a gig. Okay. All right. So Chris is asking, is he the only one with frozen video? That's probably because we're running the show through the splice cable. All right, here we go. We're going to do our speed check. This is the last test we'll do. Twisted pairs together. Here we go. Now, okay, here we go. We're going to run a speed test. Here we go. Listed with the pairs twisted. Not bad, not bad. It's going to be down a little bit from the 938. Looks like our uplink is down a little bit.
That's the cable company.
Okay, so let me make a note here real quick. The twisted down was 863, and the up was 41.9. Okay, well,
That's actually not that
tells
big
you
of a
right
loss
there
when you consider.
that, even
Now,
twisting them
what
together,
happened was
it works a
your
little
ports,
better. It's close. 800 is not bad from 938, but it does affect it. So anyway, if you have to make a splice, twist them together. If you have the luxury to do like Brett showed you, and you got the little double female adapter where you can plug the cables in and put the RJ45s on it, you can do that too. Okay, hey, thanks for watching. Okay, so what was the conclusion? Well, 100-foot extension cord, we can run data through it. We can run data through a rat's nest of cables here. You know, I'm sure it affects the impedance. You know, the reason Cat 5 is so good, and you know, each of the pairs are twisted. And I think the Bell system, one of the engineers at Bell invented a twisted system in the early years because they were getting crosstalk on the phone lines and they didn't know how to solve it. So the twisted pair, I think, was the solution for that. So each of the pairs in your Cat 5 cable are twisted pairs. So that's going to help with crosstalk and interference. And it will, and two, with a nice uninterrupted cable there, you're not going to have, you know, impedance issues or, you know, connection problems and so forth. So what do we learn tonight? If the enemy's attacking, you can do this and you can survive. All right, guys. So, oh man, I'm tired. That was some test here. I know Brett's going to talk a little about this here. He's got a neat tester there. Well, I don't know, man. We saw some differences for sure. All of them worked. Some good, some not so good. What do you think, Brett?
Well, there's a lot of factors here. The first thing is that your ports have to negotiate a connection, and they're going to be either 10 megabits per second or 100 megabits per second or a gig. And they might negotiate half duplex, where they use two of the pairs, or full duplex, where they use all four. At least they do up at a gig. And so there's a lot of factors here, and it really depends on the quality of your cables. It may depend a bit on what kind of lighting you have in the room. If you have fluorescent lights and you have electrical noise from them, you might get the ports might slow down. Now, some of the differences probably had to do with your cable company. And some of them probably had to do with whether you got errors in the packets. If some of them get through and some of them don't, the TCP/IP protocol, the protocol of the internet, will intentionally slow things down because it'll take the bad packets or drop packets as congestion, and it'll back off. So that's another factor to consider. Is TCP/IP causing the slowdown because you got errors in the packets, or all the packets good? So there's a lot to consider. And so what I do when I splice things together is I use testers like this one. This one is no longer made, and I grabbed one on eBay while I could. It's from a company called JDSU. And what you do, this is a fun tester to use. You plug your cable in here, and you put a remote on the other end, which has a series of resistors that terminate the other ends. And then you can do a whole series of tests, and I'll show you what this one does here. You get a menu here, and let's see if I can make this come through clearly on the video.
Tilt it a little bit more, maybe it'll come in.
Yeah, can you see that?
Barely.
Yeah.
Okay, it's not. Yeah, this camera.
Mm-hmm.
The font's kind of thin.
Yeah, we have a cable test menu here, and it has. You can do cable testing. You can do remote mapping if you put remotes with different numbers on them at the far ends. It can tell you the cable length, and it does that by measuring the capacitance in picofarads out to the end. And then it has a tone generator, so you can go out with a sniffer at the other end and find a particular cable that you're sending the tone down. Now, when you do this cable test, I have a remote on the other end of this cable here. Press the button, and it checks all the pairs to make sure they're all good. And it goes through them one at a time. You hit the test button, and it tells you which ones are connected at each end to which of the little pins on the other connector at the other end. And that helps you because, well, if you wired your cable wrong, you'll see that you did, and you can fix that. I don't know if you can see that, but it shows that all of the numbers correspond when you get to the other end. And it also tells you whether the thing passes muster, which is good. It'll let you know whether the cable seems to be good. And then there's a network test menu on this thing, which actually feeds data through it and does a test to see how many of the packets get through and how well they get through. So you can tell whether you've got a 100 megabit per second cable or a 1 gig cable. And so this thing is really handy. I use this a lot out in the field. It will tell you just how good everything is, and if you've done a good job. You don't want to have to in the business of wireless internet. You lose customers if they lose their connection even for a little bit, and you don't want to have to go back out there to fix it. So we use these a lot in order to help the customers get service and make sure that they get it right the first time.
Now,
I've got another one.
What? Now that's the first one I've seen it. You said it tests mustard.
Well, I said it passes. Now the cable has to pass
mustard. Yeah. I want to know how you get that mustard down those wires, man.
Yeah,
with a very small spoon.
Yeah, on the battlefield, you use whatever you've got, right?
That's right.
There you go. Tom, I'm about to blow up some of your research, though.
What are you blowing up, man? Tell me about it.
I'm going to go back and defend the lamp cord.
Yeah, yeah.
You only use 2 pairs with the lamp cord. The gigabit standard, I looked it up here. That's one of the things I was doing.
No. I used all 8 pairs.
Did you use all 8? It looked
I
like
used all 4 pairs. I used several different old lamp cords, new lamp cords. I used
okay, because it
bell.
only looked like you had 2 sections of lamp cord on that.
No, I had all 8 cables connected.
I don't know, Brett. It looked like 2 to me.
I had 8. I had all 8.
I don't know.
Well,
we're gonna have to call for a review on this one.
All right, I got them right here. How many does that look like? Let me see. How many does this look like?
his computer will tell him if he's connected at 100
All right,
megs
so
or a
look.
gig. You said to go to
There's the doorbell.
Yeah.
There's the doorbell wire. That's 2.
Doorbell wire.
That's
Love
2.
it.
That's the new lamp cord. That's 4. And then we got probably a 30-year lamp cord. It's kind of yellow. That's 6. And then we had the white transparent lamp cord, which is
And
8.
you had those all connected at the same time.
We sure did.
Okay.
We did. Now, you know, hey, man, hey, you know what? We're going to twist it, and then got let like a twist on top. Let me find it.
That's right.
I'm gonna
Okay.
unplug the Ethernet from the computer. Or stop 3 down. Let's see. Use it on top. Each side switch. Take it later. Okay, getting ready right here to twist them. There, I've got a.
Yeah. Okay.
Wait a minute, I gotta prove this. And gotta prove it. In between. See all those cords laying there? Let's go with the new mark for these. Let's just put this on the orange. We're gonna use this on the orange. And I'll sit down and do a speed check. Let's see if we can get it by twisting it into the. We'll be back in our cable. See here. Into the various lamp cords, the old lamp cords, right new lamp cords. You can look right there. You see them?
I didn't see the transparent cord. Okay.
Okay. All right. Well, I just wanted to, wanted to make
wait a
sure.
minute. Okay. Yeah. All right.
We'll let
it slide.
That we're right there now. Okay.
Now, Tom.
Yeah.
What I would have liked to see is I would have liked to look at the screen on your computer that shows the network connection and see what it said the speed of the link was, what it negotiated at. If you got a Windows computer and you go into the network settings, it will actually tell you that. So you could tell whether it thought it had a gig or not. And that's helpful.
Yeah. And I did have the polarities saying. I mean, I put the blue wire to the blue wire, the blue white to the blue white. So Mark was talking about polarity there. Okay.
Now, if you got a 1-to-1, the polarity's going to be correct. So
yeah. Well, I had already pre-marked. I had pre-marked the lamp cord. You can't tell one end to the other. So I had pre-marked the same conductor on each end of the lamp cords. All right. So your accusal of us cheating now has made me forget where we were in the show. I don't know.
Well, here I'll bring you forward, and you can jump in on me.
All right.
Back in the day, before Cat 5 cable and 100 meg, we had Cat 3 cable that was good for 10 meg, and that was standard 4-wire phone cable, the twisted pair 4 phone cable that was used for networking back in the day.
Twisted if you were lucky. Cat 3 wasn't always.
Yes.
Well, I was going. I've got a roll of 8 conductor rotor cable here. I was going to throw that in, but I just didn't.
Oh, that would have been fun.
Yeah, that would have been interesting too. All right, hey guys. Okay, so Brett, let's see. You've showed us the equipment you've got there. Was there anything else you guys want to mention about this?
No, you win.
Well, I didn't win. I just wanted to demonstrate. Okay.
Yeah.
Hey, coming up, guys, coming up in a minute, we're going to give away a $25 gift certificate here for anybody here that wants it. Don't say you want it yet. I'll tell you when. And we're going to talk about the Pico balloon. I've got a video together that shows stretching the balloon, putting hydrogen in a balloon, measuring it, and then the launch of this last balloon we just did. We'll be doing that here in the second half. So everybody just stand by, and we'll be back in just a couple minutes here, or in about a minute.
ICOM's amateur radios are the gold standard for ham radio enthusiasts, combining cutting-edge technology, unmatched reliability, and user-friendly design. Whether you're chasing DX, experimenting with digital modes, or laying a local net, ICOM radios deliver crystal clear performance and seamless connectivity. ICOM's IC7760 is the pinnacle of the base station excellence for amateur radio enthusiasts. Designed to deliver unmatched performance, the IC7760 features state-of-the-art technology, exceptional RF clarity, and an intuitive interface, all housed in a sleek and durable design. The base station features a separate remote control head and RF deck, providing enhanced flexibility for installation. Place the RF deck closer to the antenna feed point, freeing up space on your desk. You can also connect the control head to the RF deck through your home network, enabling remote operation from just about anywhere in your home without needing a PC. For more information about ICOM's amateur radios, please visit icomamerica.com/amateur.
All right, guys, let's do this. Hey, real quick, let's look at our novice pictures. We've got some new pictures that we're sending here for novice stations. You know, usually we just ask for shack pictures, and we get a bunch of them. We didn't get so many novice pictures. I think it's kind of because back, in the 60s and 70s, we didn't have these smartphones with cameras that we can take pictures with. You had to go get the film developed, and I've got very few pictures.
I don't have any.
Yeah, I mean, it's just terrible. But we got a few pictures here. We're going to look at them real quick and just see who sent something in here. And I started it off with me. That was me, 1964. I held a novice and a technician license at the same time. You could do that back then. Operated CW on 80, 40, and 15. And we could operate voice on 6 meters with a tech license. So my transmitter there I built was the T150. It was a night kit. And on the bottom center there. And then to the left is a Hallicrafter's SX140. And that receiver was perfect for me because if you look at the band there, you really can't see it. But, on some radios, the band is very small. It's like an inch long. Well, that entire band was 3.5 to 4 on the top line, 7 to 7.3 on the next line. And it actually had 6 meters on it. So it was a perfect match for that night T150 transmitter. Now, I got to give it Martin Jew because Martin, in all the stuff he's collected, he's got a T150 and an SX140 in his office. I know he's not going to have room to keep it, so I'm going to try somehow to trade him out of that. I don't know where I'll put it. But anyway, there's I think that's a night VFO up on the top. That's an ICO signal generator up there on the top. I built several pieces of test equipment. On the very top left is a electronic keyer. Most rigs now have electronic keyer built in, but that was electronic keyer homebrew. I think it had a 12A T6 tube in it. And the transformer, believe it or not, the transformer weighed about 15 pounds in that thing. It came out of a TV. One other thing I want to mention, look on the wall to the left of the window. You'll see a little black box there with coax hooked to it. I built that up. That was an electronic transmit receive switch. In the early days, a lot of people used a knife switch or a relay, and you had to switch, transmit, receive. Well, that TR switch had no relay or mechanical parts in it. It was all electronic switching through a tube. And I think it was something like a 12A U7. It might still be in some handbook, older handbook. but the transmitter stayed connected all the time through it, and it fed through that tube to the receiver, and kept you from blowing your receiver up. But so it was a total quick break-in. So that's my setup there. Oh, and everybody has to have the desk like that. And Glenn, you had one of the desks like that. That's a door. They show
Similar,
you.
except I had 2 file cabinets and the door laying across file cabinets.
Yeah, okay. Well, the RL book showed us back in 1960s that you take an old door, and that makes your desk. So that was our ham desk right there. Let's see if I got another picture. There's another shot of it there. Same equipment basically. That little desk thing, I built that in, I took agriculture in school. We learned to weld. We learned, woodworking and so forth. That's a desk that I built in high school there. Okay, so that was me. Let's see who else sent something in here real quick. And this is Mark, AB0CW. His novice call was, novice call, I think that's not exactly right.
WD8PCE.
You think a novice had a WD or was it a WN? Usually,
They switched in the later years, I think.
Did they? Okay, that says 1977. That may be possible. I would have thought that his call would have been WN8PCE, and then when he upgraded,
I think they discontinued the N
they might have
in 75.
They may have. He's got a Globe Chief 90A transmitter with a Globe 755A VFO, a Hammerlin HQ140 receiver, and he had a Q multiplier. Man, he had it all. Look at him here. He looks pretty young here. Did it say how old?
Yeah.
Didn't say how old he was, but he was a ham back then for sure. Let's see. These are novice stations again. Now here is Jim Aspinwall, and he was WN9GVF. I don't see a date on this. I don't know if that was his novice station or not. It looks like he may have been at a amateur radio club there. He was 14 years old. He grew up.
Yeah, that might have been something like Field Day.
Yeah, it looks like he's got. Is that a Heathkit that he's? Is that like?
I'm going to bet that's. It looks like the top is a receiver and the bottom is a Heathkit.
Is that an SB101? It's kind of green.
It might be an SB101. It's not an HW.
Yeah, right. It's one of the higher end. It's like the 100 or the 101, but it's got a nicer case to it.
Yeah, it's the next generation.
Yeah, I think it basically were the same radio, to tell you the truth. Anyway, there he is.
Yeah, he said he grew up as a Field Day kid, so yeah.
That's cool. That's cool. Let's see. Oh, here's our friend David Osley right here, WN4NCT. He's helped us actually run down, I think, one of our crashed balloons that we crashed on top of a school in Georgia, I think. I think it was David. He said this was about 1968, homebrew 40 watt, 40 meter crystal control. Oh man, he's a real ham there. Look at here. Military, the R45 military surplus receiver and a homebrew 40 watt. When you build your homebrew transmitter back in the 60s, you were a real, back then you were a real ham. And crystal control 40 watts. Wow. I've got this out. Here's a 40 meter crystal right here. This is the type crystals that we used. This is what put us on frequency, guys, back in the 60s. This one is on 7075 kilohertz. You just plug it in the radio, and that's your frequency, man. And the guy you're talking to, he may not be on this frequency. He may be on 7080, and you're on 7075. When you call CQ, you just kind of tune back and forth till you find somebody calling you. That's how we did it back then. The reason I got this out.
And the crystals were expensive too.
Yeah, yeah. I had like 3 crystals on 15 meters, and that's all I had. And I worked the world on 21,111, 21,150, and 21,174.
Yep.
And Tom, you're right, man. When you call CW, you crank that dial, and you would go plus 20, minus 20.
Oh yeah, yeah. I even had a guy answer me. You know, I mean, it seems like a long stretch, but I found him. A guy called me. He was on Voice, up in the Voice band.
Yeah, I've worked
And
a
I was
few
in
in
the
the
Novice
voice.
band. And he tried to insult me. I remember. I remember his name today, and this is like 60 years ago. His name was Con, and I think his call was W4EBG. I'm sure he's gone by now, but he told me my signal sounded like a piccolo. And I think he's,
Hey.
He gets on there and, he don't care what he says. But anyway, hey, the reason I got this crystal out, guys, I showed you last week the world's basically smallest radio, that had all the hand bands on it. This crystal's almost as big as the radio. I'm going to build me a 40-meter transmitter that's the same size as that little radio that I can put in my pocket here, and I'm going to make a contact on the show and show you guys. I'm going to make a contact on 7075 right here with this crystal. All right. Cool.
Yeah, now you want to get laughed at on the air, run an HW16, because with the crystal control, those things chirped like you would not believe.
Oh, yeah, yeah. It's kind of...
If you use UFO, they stabilize, but, they chirped horribly.
That's how they sounded right there, man.
Yeah, I got plenty of 5.5 C's.
Yeah.
Yeah, 5.57 C.
Yeah. All right. Hey, let's do this. Now, let me talk to you. Don't
Oh,
anybody...
wait a minute.
Oh, go ahead. What?
Before you give it away, let me
Yep.
suggest that rather than going with the first, in case you've got somebody sitting there ready to go, make it like the fifth. That way they got to think and use some strategy.
I thought about that. I'm not sure we're going to have 5 people that want it, to tell you the truth.
Well, then they can type it 2 and 3 times. So we'll get the
That's
5
true.
in a heartbeat.
Okay, so here's what we're going to do. This is a gift certificate for $25 at ARL. You can get Glenn's book with this for $9. That's a good deal. I would order Glenn's book. There may be other books.
I'll
you
even
have.
sign it
Yeah,
for you.
and he'll autograph it for an extra $5.
Nah.
Okay.
Buy me a cup
All right,
of coffee.
so here's what we're going to do. I'm going to call Hambot in here in a minute. Hambot is not going to pick the name. I've already had this. Hambot wants to pick the name. I had an argument with Hambot, and then Hambot wants to pick the name, and I said no, because you'll pick somebody that won't use it. And I said I want somebody that needs it that will use it. So Hambot agreed, and Hambot is going to give this certificate away. So Glenn, help me watch the chat room. Glenn
Okay.
and Brett and what do you think? Third person, fourth person? What do you want? What do you think?
Let's go with the fourth.
Okay, the fourth person. Don't enter yet. The fourth person that says I want it. Just get in the chat room and say I want it. That's all you got to do. And if you're the fourth person, you will win the $25. You'll win the $25 gift certificate. So don't enter it yet. Don't enter yet.
May the fourth be with you.
All right. So, okay. If you want this $25 right now, go. Enter in the chat room. Go and tell us you want this $25. Remember, we're going to take the fourth person. You guys help me pick him here.
Well, the problem is no one may start
there's Mark.
because they
He's
want to be
first.
fourth,
Mark
not
is number
first.
1. Mark's number 1. Mark, you just lost, unless nobody else wants it.
Well, he can type again.
Oh, yeah. He could. Okay, there's KC1 PFS. That's number 2. Don wants it. John wants
Doc. There we go.
it. John got
John.
it, didn't he? KC7 DRI won it. Let me write this down. KC7
There you go.
DRI. John won the $25 ARL. All right, John, we will put this in the mail hopefully tomorrow for you, and you'll have it. You've got until the end of August to spend this. But congratulations. Glad you can use it here. All right. So let's see what time it's going to be. Ooh, we're getting really close on time. We may go over a few minutes tonight. Let's do this, guys. We've launched, as I mentioned, we launched a Pico balloon for a ham club over in Russellville, where I went to college. I was a member of that club 60 years ago. We launched 2 a couple weeks ago, and we lost both of them the first day. So I felt obligated to try again, and we had a perfect launch Saturday morning, perfect launch. We're presently over, I think, the Netherlands, or maybe into Germany now. It's dark. It's going to be daylight over here pretty soon. So if you want to track the balloon, it's called W5KUB-118. W5KUB-118, and you go to APRS. And you can track it, and you can see where it is, and the speed, and all those kind of things. If you can't remember that, just go to my website, w5kub.com, and click on Balloon in the top menu, and that will take you to the tracking page. So I put together, I'm not going to talk about how we build a little bitty super small tracker or anything like that, or the solar panels or anything like that. I've had a lot of people ask about how do you know how much gas to put in, and how do you do that, and there's some of the things we do first to kind of stretch the balloon to get it at its maximum. We don't want to. We can only stretch it so far. If we go any further, we'll pop it. We got to watch the pressure and all those kind of things. So I put together a little video, and it's also going to show our perfect launch here. So let's run that video real quick, and you'll get to see it here. There's one spot that noise gets a little high. I'm going to try to turn the volume down. I hope I don't blow your speakers out, but here we go.
All right, a lot of people ask me, what's it take to do Pico ballooning? I've gone into and showed you the little tracker we build with the solar panels, and I'll put that in a different video for you. I want to show you kind of what we do with the balloon and how much time we spend on it. It's pretty important. There's only a couple balloons out there that will work. You've got to have a balloon that's not stretchy. It can't be latex. It can't be a weather balloon. They're made to destroy themselves as they go up. These balloons are 1,000th or 1 mil, 1,000th of an inch thick, and once they expand out to their volume, they don't expand anymore. And once that happens, then the balloon stops rising, and that establishes the float altitude. Now, this is a balloon we have here that we're filling up with air. We're just testing it, make sure it doesn't have any leaks or no rips, and we're testing the pressure. And a lot of people test these up to about 0.4 psi. 0.4 psi is about the maximum. If you go over that, you're going to pop the balloon. I usually try to go up to like 0.3 psi or whatever. That gets it pretty tight. And at altitude, your pressure typically isn't but about 0.17 to 0.2. So testing at 0.3 is pretty good. So let's look at this and see what we've got here. So here I'm putting air into it. And I'm going to measure how much pressure we've got. And you see right here, I have a homemade manometer. And this manometer is just a piece of plastic tubing in a U shape, and we put some colored water in it. And the manometer has been around about 400 years. It's useful for measuring pressure, PSI, low value pressure. For instance, every inch of water rise equals a certain amount of PSI. So I can look at this, I can fill this balloon up and keep putting pressure into it, and I can watch the manometer here as it increases in inches, 4, 5, 6, 7 inches and so forth. And I can tell exactly how much pressure we've got in the balloon. So this is a manometer here. Now I put a valve in line with it so I can turn the manometer off, because if I don't turn the manometer off, You can see a little valve right there. If I don't turn the manometer off, when I put air pressure into that balloon, it also goes down that hose, and it will blow the red liquid out of the tube, and it will actually blow it all over the ceiling. So I made that mistake a few times. You got to remember, you don't pressurize a balloon with the manometer turned on there. Let's see. Okay. So there it is. The input to this balloon is very small. I'm using a piece of heat shrink here. That's probably about 1/8 inch heat shrink that's in the filler tube. And I think you can hear me putting a little air in there. And then I'm going to check it again. I turn the manometer on, and I read the pressure. And it's showing about a little under, 5 inches. And I have a chart there that tells me, how much pressure. Now, the way we tell how well we're doing with the balloon, we measure the circumference of the string, and that way it will give me the exact volume of that balloon. So I can get the circumference there. I can measure the circumference with a string and then measure that with a tape measure. And then there's a formula you can use. Circumference can be converted into cubic meters per volume. So once we know the cubic meters in volume, that helps us to go into our spreadsheet, which calculates how much gas we put in and so forth. That balloon right here is a 32-inch balloon. It's not going to expand really any much bigger at all. It's going to stop expanding. That 32-inch balloon there is about 0.320 cubic meters. So that's the volume. And of course, you know, as we put gas in it when we launch, we don't fill it up tight. We put very little hydrogen in it because hydrogen is going to expand as it goes up. Now, next step here, I've got to take the air out. We got to get every molecule of air out of that envelope because we don't want it in there mixing with our hydrogen. So to get it out, I'm taking a shot back there, and on the hose that I use for input, I also just suck it out there. Now, it took quite a while to suck it out. And also, let me say this: once I expanded that balloon, I could see the circumference getting up around 103 inches, 104 inches, and I left the balloon tight, and I let it sit a couple of days. And as it sat there, stretched out kind of tight for a couple of days, it kind of stretched the balloon just a little bit. So we're stretching it to the point where it's not going to stretch anymore. So I think my final measurement was the circumference was 105 inches around that balloon. Here I am making the attempt to take the air out. It probably took close to an hour to suck the air out because, again, I'm using a little 1/8 inch tube, a piece of heat shrink. Shot back. Hope that's not too loud for you. So I can vary the rate of suction just by putting my hand around it. So you can see right there, it's not going down very fast at all. I can vary the amount of suction on it by putting my hand around the vacuum hose there and kind of regulating how much suction we may get there. I hope that wasn't too noisy. Let me see if I can get a quieter spot here. Let's see. All right, that's a little quieter right there. All right, you can see we're sucking it out. You can see how slow it's going down right there. Going down pretty slow. Again, it took probably an hour just to get that air out of there. You can see it's getting pretty flat here. We're actually going to suck a vacuum, and we're we're going to try to get every little bit of air out of there that we can. Again, this balloon is very delicate. You have to pretty much handle it with kid gloves or wear gloves. Actually, if you don't, you can damage it real easy. Okay, so now we're going to talk about how do we measure the amount of hydrogen we put in. Well, we know the volume of the balloon. We've taken our spreadsheet. We put all the numbers in. By the way, that's our hydrogen tank right there. We get that from a gas supply shop here in town. So we're gonna try to put some gas in. It just takes little small squirts because we're not putting much gas in. We're going to end up with only 7 grams of lift. For instance, if our payload is 10 grams, we're going to make that balloon lift 17 grams. So that means that balloon is going to lift the 10 gram weight, plus it'll have 7 extra of lifting power. So there I am putting the little tube in the balloon again. We're going to put some just quick squirts of air, not of air, of hydrogen into the balloon right there. Now, you don't have to worry about it until it starts rising. See, it's still laying on the table there. So once I get enough in there that it starts rising, then I need to be very careful and check it. Because if we overfill it, we've got to take some of it out. We do not want to overfill because it will go up and it will burst if we're not careful. So you can see it's coming in slowly. It's starting to rise a little bit right there. There we go. It's amazing how hydrogen gas rises like that. All right, so let's listen. You hear it? Just psst, one little squirt, 2 little squirts, not much. All right, and once we do that, we're going to take the filler tube. I'll put a little bit more in. Once we do that, we're going to take the filler tube out, and we're going to measure the lift. Now, again, if our tracker and antenna and everything that goes on the balloon, let's say it weighs 10 grams, and we want 7 grams of lift, we want this balloon to lift 17, the 10 plus 7. All right, so I don't know if I'm there, but it doesn't take much to go over. So I'm taking the filler tube out. And what we're using here are some scales. These are gram scales that are found around the house. If not, you can order them on eBay, pretty cheap, probably $15. Now on the balloon here, I've got some weights to hold it down. You can see it kind of a little piece of metal there to hold that balloon from taking off. And we also use those weights when we go out in the field to launch, so we don't, by accident, let the balloon go before we connect it up. So there we go. I'm gonna put the scales on something flat, turn them on, get them zeroed out. And what we've got is a paper clip taped to the scales, and it's zeroed out. And what we do, we hook the balloon on that little paper clip, and it pulls up on that scale, and it tells us you're at, say, minus 10. So if we're at 10, we know we want 17. 10 plus 7 is 17. So we want, we'll have to put a little bit more in there. You can see it still looks pretty empty. Not much in there, but we're getting close. Believe me, we're getting real close. There's the scales. Looks like we've got about 10 grams lift. I think on this one we were shooting for, we had a heavy tracker. The tracker was about 15 grams, so we wanted 7 grams of lift, so 15 to 7 would be about 22. So we're shooting for somewhere around 6 to 7 grams of free lift. So I was at 10. We need to go up to 22, so we're putting the filler back in. We're going to put just a couple quick squirts in. You might listen. One. That was one squirt. Come on. We're going to measure. We're going to measure that one squirt. We were at 10. Let's see what we got. All right, we zero the scales out each time, hook the balloon on. And the reason you have to do this inside, if the wind is blowing the balloon around, you can never get the reading because the wind will whip that balloon around and the scale will be going, 10, 12, 15, 8, it'll just be going up and down because a gram is not very much. All right, so obviously it didn't have enough. Here we go, another little bit of squirt. Here we go. Let's see what we get this time. I might have put too much in. It's still pretty flat. You can see it doesn't have much in it. And I got to zero the scale. We're going to hook it on the paper clip, and we're going to see what the weight is, what the lift is. Here we go. Remember, we're looking for 22. And what is it? 22, 22. Will it be close? Let's see if we must still be a little bit low. So man, now we're getting close and it's getting tricky here. So we put the filler tube back in. You're going to hear short bursts now. I may have overdone it. Let's see. $23.5. No, we were shooting for 22. We're shooting for 22, and we got 23.5. Now, I think I left the filler tube in. I turned the balloon upside down, and I squeezed a little bit of hydrogen out into the shop there to get what we wanted. Now we're out at the launch site. We're out at the launch site. I'm unrolling the antenna. The antenna is a vertical dipole. It's trapped for 20 and 10. This is the first time we ran a dual band tracker on 20 and 10. If you notice there, you can't see the wire. The wire and the string, the fishing line is so thin and so small, you can't see it. It's very difficult to see. And you got to be very careful. The solar cells here can break. If you sneeze, they'll break pretty much. Okay, so I'm tying the top half of the antenna. So the dipole, half the dipole goes from the tracker up to the balloon, and half of it hangs below the tracker. So now I'm tying the string and the top half of the antenna to the balloon. Again, you can see the weights on there to keep us from losing the balloon. We've come close to losing a balloon a time or two.
See this line here, man, it is so small.
You can see it looks like I'm not tying anything, but I really am tying the antenna onto the balloon here. We'll do a good double knot there to make sure it doesn't come loose, and we'll be ready to launch. Okay. The thing you got to watch out for, don't step on the antenna and break it. And you can't see it there, so you got to be
this is
really careful.
W5 KUB 118. We're launching this for the Arkansas River Valley Amateur Radio Foundation over in Russellville.
Now, one of the things, all this takes a lot more time than what you're seeing here. Probably to stretch the balloon to its maximum, to where it's going to stop stretching. It might take you, 3 or 4 hours. And then again, you want to let that kind of set in for a day or two, and let it kind of do the stretching on its own. And another reason we fill it up with air before is this balloon comes all folded up. It's kind of like saran wrap, and all the folding kind of sticks together. And we're afraid when it gets up there at 30, 40,000 feet at very cold temperatures, it might not want to open up very good. So we want to make sure that we open it up. Also, when they make the balloon, the seams, they stamp it with a machine to make the seams, and sometimes different layers are kind of stuck together. So we want to make sure it's filled out good. That takes, you can spend a couple of days on that, and then you can spend several hours in getting the gas volume in there correctly. So, and this doesn't count all the time to build a tracker, build the solar panels, test it outside, program it, and so forth. So, you got 3 or 4 days, maybe a week to get a flight ready. But we're fixing to launch this one right now. It's going to be a cool launch, nice day. You can't launch. Also, you cannot launch if there's any clouds. If that balloon gets any moisture on it, it will come down. It'll be a failure. It'll be a disaster. So you gotta launch on a clear day, and it was almost no wind that day. On a windy day, you got to be careful. You'll tangle it up in some trees, 100 yards away. So we were real lucky on this one. So here we go.
Yeah, be careful. Take your thumb off the sails, man. They will break so easy. All right, Ed, if you'll take this, go ahead and lay that down. There you go. And if you'll take this, I'll take the tracker. Let's get it. We're gonna give you a countdown. And Ed, I guess just let it go. We got 5, 4, 3, 2, 1. Here we go. And we have liftoff. He's already taking the tracker.
There we go. You can see the tracker hanging about 20 feet below the balloon. That top half of the string here, that's the top half of the 20 meters, and at 20 meters, half of it hangs below that. I want you to watch how far Ed's camera zooms in and out on this balloon in a minute. It'll be
This
coming
thing's
up.
over my head straight up, man. That's good.
It was a beautiful day for launch,
At
let me
least
tell
it's
you.
above the trees.
Watch when he zooms out in a minute. You'll see how far the balloon has traveled.
Where is it? I lost it. Oh, there it is.
We're almost going into the sun. This was launched on Saturday morning at 9 o'clock, and it's heading a little bit east-southeast.
Zooming out to see how far it is.
Look at that zoom. Watch this zoom. Look at
Gone.
that. Look at that.
Wait a minute.
We're almost going into the sun. This was launched on Saturday morning at 9 o'clock, and it's heading a little bit east-southeast.
Zooming out to see how far it is.
Look at that zoom. Watch this zoom. Look at
Gone.
that. Look at that. Let me see if I can repeat that zoom. Watch this. Watch this.
Zooming out to see how far it is. Gone.
If you look, you're going to see the tracker hanging below it here. Now, when this thing gets up in the jet stream, we were doing 145 miles an hour,
Yeah.
and it's not really swinging around. Everything is relative. The tracker and the balloon, they seem like they're still. They're both moving at the same speed with the wind. So, the tracker, there's the tracker right here. You can see it below. The tracker's not blowing all around under there. I'm sure there's some movement under there, but it's pretty steady. Probably just about like it right there.
That's 2 minutes and 30 seconds in flight now.
That was a good launch. So, I didn't cover it in this video, but that's the tracker we build. Actually, we started building those from scratch. We had the boards made, and we ordered all the parts. Parts were really, really small. We had to use a microscope to build this. And in the meantime, the PCB board company that we have that was making our boards actually is able to put these trackers together and build them for us with their pick and place machines. So it comes back now very professionally built, under the way electronic boards are built now by board manufacturers. So, but that's a picture of a tracker right there. And there's a shot of the solar panel. We've got eight cells. Each of those cells is supposed to be 1/2 volts, so 8 times 5 should be 4 volts. The problem is that when you get up high, very high, above the clouds, you got a lot of ultraviolet light and different things, and those cells actually put out more than 1/2 volt. Actually, they were putting out about 0.65 volts each. So our maximum voltage with 8 cells was about 5.2 volts, and we didn't want anything higher than that because some of our parts on our circuit board are only rated at 6 volts. So this is the second build for this launch. The first build.
Okay, guys, that's pretty much the video there. I want to show you one thing. This is the first time we run a dual band 20 meter, 10 meter. And I want to show you how it worked out for us. Take a look at this. The yellow lines, this is the balloon halfway across the Atlantic. The yellow lines is 20 meters. You can see who's picking it up on 20, and the pink line is 10 meters. So between the 10 and the 20, look at all the tracking we get. We were getting tracking up to 7,000 to 10,000 miles away, and that's about 1,000 miles per milliwatt for a little 10 milliwatt transmitter. And there were times of day where 20 meters just wasn't working at all. But 10 meters was on, and we were getting the reports on 10 meters, so that worked out real well for us there. I don't know if I think there was one more slide I was going to show you, but I don't remember what it was. We can see the forecast of where it's going to go. Let me see if I can show you the latest prediction on where it's going to go. May not be able to here. Okay, well, that's enough. There's a tracker right there. Okay, well, anyway, guys, that's our story tonight, and we are sticking to it. So, Glenn, did you learn anything tonight? How come I'm not getting any audio on Glenn? Was that his fault?
That's me. Yeah. But one of the things with Ed's voice, I kept expecting to hear the NASA courtesy beeps.
Oh, yeah?
Because he just had one of those wonderful narrating voices, about the flight and everything. And that Zoom was quite incredible. But
man,
yeah,
wasn't it though?
It was,
I couldn't believe it, man. When he zoomed out, you couldn't even see it.
Yeah.
Man.
No, that was a beautiful launch. I mean, it's just perfect. I love it.
Yeah, it was. It went pretty much straight up. And it seemed to be doing real good. I think tonight around 1 o'clock Central Time, it may come back on because it's been in the dark over there. It's still traveling, but it's been in the dark and off. We did shut down. We went across England. We did shut the transmitter down as we went across England tonight. But I understand now that England has changed their rules. And if you're running under 500 milliwatts, you can have aeronautical mobile ham radio. So it's legal now. It's just, but we shut it down as we crossed. I think we will be over Germany when it wakes up. It's going to wake up somewhere around 1 or 2 o'clock our time today. Let's see. Okay, Bill was talking about. Bill had a balloon in the
There's
air
a
about the same
7-hour
time.
time difference.
Yeah. What was that? What was that, Brett?
There's a 7 to 8 hour time difference to
Yeah.
go into that part of Europe.
Yeah, it's about 7 hours difference. So, 1 o'clock tonight, our time, will be about 8 o'clock in the morning, their time. The sun will be coming up. So that's one. If you want to try to track this, go to our website, w5kub.com, click on balloon in the menu, sometime after 1 o'clock, and you'll track it. You'll see it on the map, and it's been real steady. It's been holding really steady. And I think we should be over Germany. Our path is going to take us over Germany, Poland,